handshakes, touching stuff, taking your jumper off, all seem like harmless activities, but they carry a risk of getting a very mild electric shock. Yes, it's electrostatics. Some things become charged with static electricity when you rub them together. This happens with insulating materials like wool, acrylic and plastic. Where does the electric charge come from? As you might suspect, it has something to do with electrons. Remember them? The incredibly small, negatively charged parts of an atom. If you rub your sleeve against a balloon, some electrons move across. This makes the balloon negatively charged and your sleeve positively charged. Because the materials of the balloon and sleeve are electrical insulators, the charge can't run away. It just sits there, being a charge. Try this with a conducting material like metal and you're onto a non-starter. Any electric charge you rub onto a conductor spreads out and runs away to the earth if it can. These two balloons are negatively charged, and when you bring them together you feel a force. They try to push away from each other. Two positive charges would repel each other in the same way too. But positive and negative forces attract each other, as you might have guessed. Charged objects and uncharged objects are also attracted to each other. So attraction doesn't mean an object has charge, but if a mystery object can repel a charge, then it must have a charge of its own. The charge on an object can be discharged by connecting it to earth with a conducting material, like metal wire. If the potential difference is large, then you get a spark. This can be dangerous, especially in petrol stations and airports where sparks can cause fire. When charge moves, we get an electric current. A balloon doesn't carry much charge, so touching it is okay, no danger. Being hit by lightning is a different matter. A huge current flows through the body to earth. Extreme danger! Less deadly is the way static electricity attracts dust and dirt to insulators, like TV screens and computer monitors. And it's static that makes some clothes stick to you and crackle with sparks when you take them off. Oh, exciting! But it's not just fun and games. There are useful applications too, like in power stations. The problem with burning oil in power stations is it gives off smoke. Smoke is made from lots of tiny particles of carbon, which can damage buildings and cause breathing problems. But science came to the rescue with the invention of the electrostatic precipitator. Catchy name. So how does it work? Well, it precipitates using electrostatics, obviously. The problem is to remove the smoke particles before they leave the chimney. Solution? Give the particles negative charge, then put positively charged plates in the way. The particles stick to the plates and don't go up the chimney. The particles are knocked off the plates and dropped into containers to be taken away. Bad particles. Photocopiers use electrostatics too. They have a positively charged copying plate. The light from the photocopier hits the plate where the white areas of the picture are. The plate is specially designed so that this causes the electrical charge to leak away from those areas. So only the plate areas under the dark parts of the image are left with positive charge. Black toner particles are negatively charged and stick to those areas. The toner is transferred to the paper and you get the final image. Final image, final image, final image, final image.